Good evening or good morning whenever you're watching this. Since I've got it recorded, you can actually attend class at any time that's convenient for you. So this unit, we're going to start into probability. This is the basis. So probability is about chance of things happening. And basically, to do probability, we have to first count how many ways are there for something to happen, and then it's dividing by sort of how many ways one thing can happen divided by the total number of ways. We'll get to that, but first we're going to build some methods for doing the counting. Okay, so we've got to be able to count accurately and count large number of things easily to be able to do probability. That is our stepping stone to getting us to statistics, because statistics really is about what's the probability of something happening. That's we turn it into a percentage. So we'll see how that all works. Today we're going to take a look at counting methods. Okay, so first section is just the fundamental counting principle, and that's based upon multiplying. So what does that mean? Well, let's take a look. So it's a way that we're able to determine the number of possible outcomes for a particular situation. We count how many ways something could happen. So here's, again, a mathematical definition. If there's m items, so m could be, say, 3, and then there's a second group where we're making some other choices. Say on a menu, you have so many appetizers, you have m appetizers to choose from, and so many entrees. How many different meals could you make based on having an appetizer and an entree, m times n? So that's what it's going to be. And let's see visually how that works. So we can use a tree diagram to show that all we need to do is multiply. So let's get away from the menu choices. Let's go to say that someone in your closet, you have 2 pairs of jeans and 3, I don't like when they put numbers as letters, so why not just go like this, 3 different t-shirts. How many outfits could you have composed of a t-shirt and a pair of jeans? Visually, we can see he's already got a t-shirt on, right? But 3 different colored t-shirts. You first choose which jeans, whether you're going to wear the black jeans or the blue jeans. So that's 2. And then from each of those choices, you've got 3 shirts. So there are, if you count this, 1, 2, 3, 4, 5, 6 different outcomes that we arrived at, and it really is 2 times 3. And that's the principle that we're going to work with. Okay. The way I like to think of it is you have a first choice. You always really have a first choice. Now, yeah, you could have put the shirt on first or the pants on first, but you do have to make a first choice. But with multiplication, the cool thing is it usually doesn't matter which one comes first. Whether you choose the jeans first and then the t-shirt, or whether you choose the t-shirt first and then the jeans, both of them end up with 6 different outcomes. And again, we're going to use that later to calculate probabilities. Okay, so here's one where we're back to the appetizers, 6 appetizers, 14 main courses. Now you could try to put this all picture together, but you could see it's going to take up a lot of room with 16 and 14. But what you think of is that your first choice, you have 6, right? There's going to be 6 appetizers. So that gives you 1, 2, 3, 4, 5, 6 different options. And then from each of these options, you get 14 main courses spreading off. So there's 6 times 14 will give you your total. And I'll let them do the work. 6 appetizers, 14 main courses, and indeed 6 times 14 is what we have. We have 84 different meals we could come up with that would consist of an appetizer and a main course. That's all there is. And again, I just kind of say, well, I have to make two choices, a first choice, a second choice. And it really doesn't matter, but I have 6 different choices for this first one. And then I have 14 different choices for the second one because they're in 2 different categories. When we multiply this, we get our 84. So you'll see me doing this a lot. Just underline how many choices there are. Let's fill in the blanks. Okay, so here's another one. When we have 2 groups, let's see if we could figure this one out. What if we have a series of, because like that, you could have had appetizers, the main meal, and a dessert. Or you need shoes to go out, right? So you have 2 pairs of jeans, 3 t-shirts, and then 2 different pairs of sneakers. And again, that is it. Yeah, you've got 3 different choices, and all you have to do is fill it in. Well, I've got 2 to choose from at the beginning, 3 more choices to make, and then I've got 2 more choices to make. So when you multiply all this out, it gives you the total possibilities. And again, here's a diagram, 2 choices, 3 each, depending upon which one you make, you get 3 choices each. And then depending upon one of these, you either get the black or the red sneakers. So if you count down here, you count 12 different looking outfits, right? Some similarities, but each one of these 12 is actually a different outfit. Okay. Just how many decisions do we have to make? How many choices do we have for each decision? Multiply. That's what this whole section is about. Okay. Planning a course section. Okay, there's 8 sections of math, 5 sections of English, 4 of humanities, and you have to take one of each class. And that's, again, we'd have to assume that there is no scheduling conflict, because if there is, then you couldn't take one of them. So it really is, if this is the real case, we have 8 for our first class, 5 and 4. And again, order is not really important here, because I could do this multiplication in a different order and I get the same answer. So I get 40. 40 times 4 is 160. Right? 8 choices, 5 choices, 4 choices. 160 different schedules that you could come up with depending upon these, having to choose these 3 types of classes. Okay, here's another one. What if you're taking a test and you're randomly answering? I don't know why they use tests. You shouldn't randomly answer. You should know what you're going to, you should study and know. But if there's 4 answers, 1 correct answer per question, right? That's usually how it works. If you take these 4 choices for each question, leaving nothing blank, and how many ways can you answer the question? So it has, let's see, it's up here, 10 questions total. Each has 4 choices. How many ways can you answer the questions? Well, again, you have a number of questions. You're going to answer all 10 of them, right? Each of those 10. So this is a little different. It's not 10 times 4. Notice it's 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll come back here, 10. There are actually 10 choices. Each question you have a choice. Each question you have 4 choices. And they're, again, A, B, C, D, or whatever it is, you have 4 choices, and you're going to have 4 each time. So actually, when you've got, multiple decisions to make, and each of those decisions really the same, but might be different, right? Because this is question 1, 2, 3, 4, so forth. You're just going to multiply by 4 10 times. So that's 4 to the 10th power. Okay, so notice question 1, 2, 3, they didn't put all of them down, but you got 4 choices for all of them. So what is that? That's 4 to the 10th power. Okay, so this is going to be in questions like for telephone numbers, how many digits are there? License plates, how many digits are there? And then how many choices do you have for each? Let's see, I think they don't, let's see if they do a license plate one. I can't remember. Yeah, here we go, telephone numbers. So you have 3-digit area codes and a 7-digit local telephone number. Now, one of the things is that for area codes, they cannot begin with a 0 or 1. That's just a rule, because usually you use the 1 to long distance and 0 to get to the operator. So how many different telephone numbers are possible? So again, what we have to do is, let's go out with this. We've got an area code that's 123, so this is going to be our area code. And then we've got 7 digits, 123-1234. The first number cannot include 0 or 1, so how many are there? There's 2, 3, 4, 5, 6, 7, 8, 9, 9. So that's 8 different choices for the first digit. Now the second digit, we can use 0, we can use 1, we can use them all. So there are 10 there, 0 through 9. There's 10 possible here, and then out here there's area codes and local telephone numbers cannot begin with 0 or 1. Local telephone numbers cannot begin with 0 or 1. So this one also is only going to have 8 choices. All the rest will have 10. See how that works? So what do we've got? We've got 8 to the second power times 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th power. Now, using 10 is a good thing because it's 10 to the 8th power. You really just put 8 zeros. It's a power of 10. 8 squared is 64. And then we're going to have 8 zeros after that. 1, 2, 3, 4, 5, 6, 7, 8. That's like 6,400,000. Let's see if we agree with the PowerPoint people. So yeah, we did the same thing. They took the same approach. Here's the 8. There's the 10s. The total number of different telephone numbers. So they just wrote it all out, but I could just see here, there's 2 8s. There's our 8 squared. And then 10 to the 1 to 8th power, right? And so 10 to the 8th, 8 zeros. 8 squared, 64. So there's our 64 with 1, 2, 3, 4, 5, 6, 7, 8 zeros behind it. Okay, it all works. So we're just counting. But we're finding ways to count large numbers of things.